In this video I want to show you the workflow I use to construct this rotational knob, which is a spare part for a vintage radio that a friend of mine has got, and his problem was he lost one of the knobs where some corner broke out, and we decided to reconstruct it from scratch. So it's basically revolution and some quite nice construction for the detents here, and then more or less a straight ahead construction with no very special features, no very special things, to construct the bottom part with a bar that locks the knob against rotation, so it will only rotate about 200 degrees, somewhat alike, and an inset for the screw. So that's basically the whole construction as I've made it. Good, so let's start. I'm gonna use FreeCAD 0.18 in the version 16079, which at the date of recording, which is on the 31st of March 2019, that was the version that was released as the FreeCAD master version, or the released version for 18. And for a while I'm going to use this version. Later I will probably in the summer or such, I will switch over to showing you 0.19. In the moment it makes no sense to show 0.19 because it's not even clear where the road goes with 19. There's probably a lot of deep changes coming. So we talk about 18 as the normal release version for work. Okay, let us start. As usual, just for those who've never seen another video from me, I will use gesture navigation if you want to follow my mouse movements, etc. And we will work in the part design workbench, which is my preferred way to work with FreeCAD. This time we will create our sketch on a different plane as usual, because it is a rotated object. So let's start with a new file, create a body, create a sketch, and select on which plane it ought to be. So this time we will use the YZ plane. So the geometrical figure that we're going to use is a polyline, which is a line assembled of several individual straight lines, and I'm going to try to do this with auto constraining. Auto constraining, you can see in the moment I touch the center line, there's a little symbol coming up right to the cursor showing me this will be a constrained point on object. We're going down until the center point turns yellow, and we can see we have two auto constraints being added. One is the point on point auto constraint or coincidence, and the second one is vertical constraint. And then we're going over to the right, which gives us a point on object and a horizontal constraint. And as we're doing this, let me tell you, sometimes the constraints which are generated automatically are redundant, and I switched on auto remove redundance. So this means even though it showed us this is going to be a horizontal line, it didn't make it horizontal, because the horizontality is automatically done by having these points on that line, as the line is horizontal. So it took away this constraint by itself, as that is selected here. Good. So let's go over then the main part of the knob. As you can see, I don't really care about the values. I just sketch how it will probably look afterwards. Okay, using the right mouse key I end this mode, and first thing that you always should do is just have a check whether your lines are really connected, which in this case is okay. And sometimes, which I'm going to do here, before you start to work out your polygon here in a manner of 150 constraints, and afterwards you find, oh, it doesn't create a pad or it doesn't create a revolution because it isn't closed, just close it once and then let it create a feature. You can create a pad from it, which isn't what we want, but you can also start and create the revolution, which is the one we need here. I'm just moving down the stuff from this place. So we create a revolution feature which rotates the sketch around an axis, and that is working. So we can go back into our sketch by double click and start to add the values that we need for it. Okay, let's start with the linear values, and this line will be 25. The height here will be 20. Oops, that switched something in the view mode. Going back. If you don't really select it, you have the problem once you type, it will switch your viewpoint. So that's gonna be 20. Let's go back to a more decent side and move the things a little bit more into their final positions. So between this point and that point in horizontal we will have 16 millimeters, and we will have another measurement of 2.5 millimeters. Oops, that was wrong. Always make sure you have the proper settings for point or comma. 2.5. No. 2.5. It's German Windows, so I need the comma. In the States or somewhere you might need the decimal point. So we have this one, we have that one, and what else do we need? We need the height from here to the bottom, and this one is from here to here 6 millimeters, and that basically gives us all the needed measurements. We need one more constraint, which is this line shall be vertical, and the next is we will take away this line and we will replace it by another construction, which is going to be an arc, and that arc shall be not higher than this line, which is having to be horizontally. So now we don't have this height anymore because it was fixed by that point, and there we need two things. One is this will be a little bit lower, and we need the height between here and here. So as I removed the line here, we now have this one floating, and we have to fix these 2 points to the same height, and that is done by a horizontally constraint. So this is going to be where the arc will end. So let's start creating an arc first. We need a center point, and we estimate the center point to be somewhere here. We will start at this point, and we will approximately go over to here. These 2 points shall be coincident to close our mixed polygon, so we make them coincident. And what we need is, we now should define that whatever radius we choose and whatever center point position we choose, it should not move over this line. So I create a helping line in the blue help line mode, put it on here, and I say this line starts at this point, coincidence, and it ends at this point, also coincident. And the radius of the arc shall be tangent to this line. So this fixes our center point at the center line, and whatever we do, we can be sure it will not move over. So finally we can define that this height shall be 2 millimeters. So now we have our sketch complete that defines the profile, which we're gonna rotate now. It's fully constrained, that is okay, and we close. And now we simply create a rotation. And it already looks a little bit like a radio knob, doesn't it? We can close this. The next step is, as usual, I will click to save, name it, and continue to work. Now we're going to create the sketch that gives us the detent, which cuts out a piece of our revolution. To make this sketch, we have to think a little bit. Finally, the detent should just cut out something here in a trapezoidal way. And to make this happen, so it cuts out exactly from the outline or from the radius of this circle, we have to construct it a little bit tricky. Okay, how do we do that? First we create a new sketch. We put this sketch on the XY plane, and we switch off our revolution, but we switch on our first sketch. And as we look, this sketch appears to be flat on our z-axis. And as we created it in YZ, we look to it from this view. So if we switch our view over to the side view, we can here now see where it is. And this is the corner, or this is the line, the edge, where we will finally find our radius. So to make this our defining element, we reference an external object which we see as a point on our center line. But this point gives us the distance. So we can switch that sketch off now, and we start by creating two lines. These two lines will give us the angle that finally leads to a fixed number of detents around the circle which have a defined angle. So in the end they give 360 degrees. Let's construct this finally. I put these 2 points on the origin, and let's define the angle. And I define the angle using a math expression which is pretty easy in FreeCAD, which is pretty easy. We can just say 360 divided by 24 teeth, and this gives us 15 degrees. We just have to move it to the right place. Let's try to move the angle. Good. So the next thing that we need is we need the length for the detents, and to make sure that the detents start from the outside of the circle and just go into the circle, not creating something that is probably on the radius or not on the radius. I want to have them a little bit outside. So what I'm doing is I'm creating another line which has to be horizontal and which has to be on this point. And when we switch our revolution on and off, looking from the bird's eye view exactly, we can estimate these 2 points where these helping lines intersect with that line will be a little bit outside of the radius, and that is what we need in this case. That makes us a secure cut into the radius. Good. What do we need? These 2 lines, or these 2 points, should fix the line symmetrical to the center. And recently I got some comments from a couple of guys who had problems with constraining asymmetry. First, select the 2 points or the 2 objects which are to be symmetrically, and as the last object select the symmetry line, and then it will work. If you do it vice versa, which means select point, symmetry line, point, that would not work, not give a symmetry. Sometimes this fools people. In some cases it works. The solver can sometimes find the symmetry, but mostly it won't. Good. So let's fix the length by putting this point on this line. And that's more or less what we need for the helping construction. We want to fix this point here. That has nothing to do with the construction. It just makes sure that in the end our construction is point on line symmetry. Okay, so that's all we need. These points are defined, and the next is we now want to have our real lines. We switch on to standard line mode and we start and say, okay, first this line exactly goes along here, And next is we have a line that goes somewhere here. We need a line that goes somewhere from here and somewhere from here. What we want is these two lines should also be symmetrical. We fix these lines here. 1, 2. Be sure at least one time you fix it on the blue line, or even better, I go back and I move my white line a little bit out here because that one is not yet fixed to it here. So we fix this point on this line, fix this point on this line. Here we directly fix on that line and we fix this one. We want to have this point and this point symmetrical to the center line, and the same here. The length at the inner point of the detent I want to define as 1.2 millimeters. 1.2 millimeters. And at the outer line, the definition that I wanted to have is that the distance from here to there is 2 millimeters. So first put the line onto these points by coincidence constraint. Select exactly this line and give it 2 millimeters of width. So last thing is we have to constrain this line to be exactly this length. Let's look what else is missing. We have 1 degree, and that is the depth of our detent, and the depth of our detent is defined as to be 1.5 millimeter. 1.5 millimeter. So the detent is now ready, and we look, switch on the revolution and create a pocket. So first we don't see anything. A reason is obvious, because the pocket starts at this plane and doesn't go into, or doesn't go deep enough into, so we choose through all. Still got nothing because we need to reverse the direction so it goes upward. So we have the detent, but it looks through all of it. Now how can we move the sketch to this plane? There's two possibilities. One possibility would be we create a datum plane that lies on this height. It would not make a lot of sense in this construction because there's only this line on that height. It's not needed that anything else is on this height, so it would be a little bit shooting at the bird with the cannon. So the better way is, in this case, we just create an offset for this sketch. And to make sure the offset is always at this point, we go back into our first sketch. And in the first sketch we have this 6 millimeter height. We double click it and we give it a name, which is called /. slanted height. We close. We select our sketch, and now comes the tricky part. You may have started to work with offsets of sketches or other things, and you may think, I choose the 3 points here, I go in there and I try to put in a constraint to our first sketch's height. That doesn't work because in this dialog the equal sign does not bring up the dialog for creating a reference. So we gotta go out here, but luckily if we open the tree here to the position and we go to the set position, in this case we can type the equal sign, type in sketch, C for constraints, slanted height, and it gives us the 6 millimeters. So fine. We have the blue hook here, which tells us there is the need of a recalculation. We do this by using F5, and this moved up the sketch to the right position. We can check this. Yes, the sketch is where it ought to be. Sometimes when you do such movement of sketch offsets or even other offsets like the offsets of a datum plane, and you do this in the dialog here or in this dialog, the problem is that with the version 18 on the screen your sketch is suddenly looking like it is not on the proper plane anymore. Don't worry, it just looks as if it is. If you save your drawing and you reload your drawing, or you mark your whole drawing and recalculate it, it will suddenly move to the proper position again. So it could have changed its orientation, but in this case luckily it did not. But beware, sometimes that may happen. Okay, so we have our detent, and next is we select the pocket and we create a rotated polar feature. What we want is, as I keyed it in the calculation, we want 24 occurrences on 360 degrees, and that gives us our detents. That looks pretty good. The next thing that we want to construct is a pocket feature that creates a cylindrical hole from the bottom into the construction, but not through the construction. So to fix the length of it, we go back into our sketch. We have to move it somewhere, and we look from the bird's eye view, which isn't correct, and that is by principle what I told you. It appears as if that sketch is now on the XY plane, but it isn't, and that is just a visible flaw, but it makes it impossible to select anything here. So I have to close, file, close, and reopen, and then when I go into the sketch, I can now see the sketch from its proper view. If I look from the top, it's not visible. If I look from the side, it's visible. So this is a annoying flaw in 0.18, and it turned out relatively late in the development, so it wasn't fixed in 0.18, but for 0.19 there is already a ticket open, so we can expect that this flaw will be away in a couple of weeks or months. In the moment we have to live with it when we move objects with their properties, and it's known that it works with sketches, and it's known it may be sometimes with datum planes or other datum objects. They will not be represented properly. Okay, but that's where we're here for, to show you where the problems may arise. Okay, so I select this height, I double click it, I give it a name like total height, and if we really want to make it correct, we should select this little height and say our final cylinder should not be higher than this height minus, let's say, 2 millimeters. This gives us enough room here, so it will be a robust print afterwards. So we take this height and double click, give it a name of let's say detent height. We close it. So creating the sketch for the axis hole is relatively easy. We create a new sketch, XY plane, and we switch off our polar pattern. We create a circle, and this circle gets a diameter of 6 millimeters, which is 3 millimeters as the radius. We just make sure it's centered. Constrain point-on-point coincidence. We can close it, and we create our pocket, and the pocket needs to be reversed, and we can now define the length with a formula like equal sign sketch dot c total height minus, and open brackets, again sketch constraints detent height, and we wanted to add 2 millimeters to the detent height. Okay, we need the millimeters in here so it knows what the 2 means. Good. So if we now want to see if that worked, we use the clipping plane, and we see that looks pretty nice. It's 2 millimeters below the inset of this visible rounded feature. So this is what we need for this hole, and the next thing is we need a hole for the screw and a hole for our rectangular nut that holds the screw. We will put this also onto the sketch for this hole, but first let's create the hole for the screw. Again, we don't need any fancy things like datum planes or such. We can simply create a sketch, and we this time create the sketch on the XZ plane. The sketch itself is not more than a circle, and we want to move that circle downward so it will also be on a proper height. So let's first define how large the circle is, and it shall be for a 4 mm screw, so 2 mm of radius. We switch off our visible pocket, we move it, and we fix it to the vertical line, and we define its height again using a reference, and the reference is that we say equal sign, and from sketch, from the constraints, we want to have the slanted height, and to the slanted height we want to add 2 mm for the radius, slanted height plus 2 mm, and we add the radius, which is again 2 mm. So this would be the slanted height, 2 mm above it, and as we define the center of the hole, the 2 mm, which are the radius divided by 2. So this should, if we look again, put it into a place that's high enough over the slant and still not too far upwards. So that's pretty nice, and all we need to do is, it's fully constrained, we close, create another pocket, again reversed, and through all. So voila, there we have the pocket, and as we can see, the pocket goes inward because it starts from the inside. So what else do we need for the base construction? As I said, we need the hole for the inset screw, so we go back here and we switch on our pocket, but in this moment we don't know how far we should go in with our set screw, or we better say we don't know from where does the set screw come. Okay, we have the possibility to switch that sketch on, and we can see the sketch lies here, but actually we don't really know where it goes. We have two possibilities. One would be the easy way, that's what I'm going to choose. I just put it in here, fix the view to top so it doesn't look slanted, and the width of this for the M4 set screw is 7 mm. The height is 2.2 mm. Oops, 2.2 millimeters. It needs to be symmetrical again, and from here to here we want to have a distance of 5 millimeters, so it's 3 millimeters away from 2 millimeters away from the edge of the bore, and that's enough. We don't need any more. It's good for the print, and still the distance to the outside where the pressure is gonna be put on is far enough. Good. So fully constrained, we close, and we can see, oops, we choose the wrong side. Well, no big problem. Wrong sketch. Go in again. Remove this, or better, just change the direction to -5. So it goes to the opposite side, but there, that's not so good because we have to add the 2 millimeters, so we better do it just once again with 5 millimeters. Close, and we can see it's in there, and it has the same height as the bore itself. Let us try if we can. Good. So finally, the last thing that I need in this construction is the structure that takes off a little bit from the bottom for its angular constraining in real life. So again, we can switch that one off. We create a new sketch. We still have been in that sketch, so first we have to deselect, create a new sketch. Again, XY plane, and switch off that pocket. So let's create what we need. We need an outer diameter, a cylindrical object. We need an inner diameter, and we will need 2 lines. That's all we need. So let's start constraining. That's for sure horizontally, horizontally. I know that the radius of this circle, that's what I took from the original, is 20 millimeters, as well as this circle has a radius of 6 millimeters. I know that this line is in here, and I know that this line is tangent to that line. This point, let's start with first selecting the mode. Put this point here, put this point here, put this point, come on, this point here, and this point here. As you've seen, I didn't care about this circle moving. That's no problem. I can finally move it in here and constrain it to the center. One, two, center, and this one also didn't make it in the first try, so we finally constrain that. Good. So what else do we know? We know that the bar width is 3 millimeters, and that gives us all constraints. And in the end, what I have to do is I use the trim tool, and I'm cutting away this one, and this one, as well as cutting away this and this one. So this gives me what I need. That creates us a new degree of freedom, because unfortunately I was cutting away the points that defined the height. So I define it again. Sometimes if you do such constructions where you do cutting and so, it makes sense not to define your constrained dimensions first, but finalize the shape of the object and then create your constraints with numbers, because you may, as you've seen, take away your reference point. Okay, so let's create a new pocket, and I know that this pocket is to be 2 millimeters, and as well it's got to be reversed direction. So that is all we wanted. That's nearly finished. The only thing we can still do is to make it look a little bit nicer. Here we create a fillet. 1 millimeter is okay. Much more doesn't work because then it's too much. It would go over the outside here and can't go into the detents of the teeth. So the last thing is, and that's better if I do this in wireframe mode, is I select each of the detents outsides, a little bit of tedious work. I'll tell you later when I'm finished why I'm doing this at that stage. So we cut them all and we create a chamfer of again 1 millimeter. Why have I done it last? I could have put the chamfer on the detents before I create a polar pattern, but then I would have needed to create a polar pattern from the detents as well as from the chamfers. So it would have meant 2 polar patterns being calculated, and as we already know, FreeCAD is getting a bit slow when we deal with polar patterns. We would have created us more havoc than selecting them finally. And as I've already mentioned, and we see this as a problem every now and then in the forum, fillets and chamfers really should be the last thing you put into your drawing, or you put in, always should be the last thing that you put into your construction generally. Don't do this early. So that is finally all we wanted, and the last thing is I select my chamfer and I go to the mesh design. I create a mesh from the shape, standard mode. I switch the 3D drawing off, just let the chamfer exist. Have a look at the resulting wireframe. Looks pretty nice. And analyze the mesh, evaluate, analyze completely, and we get duplicated points as well as we get self-intersections. That happens very often when polar patterns are involved, because what happens is you don't actually just create a polar pattern out of the faces, you also duplicate internally the circle, and that leads to the duplicate points. And if you export this sketch now, some more simple slicers like Slick 3R, older Curas or such, may have a problem to render this as a 3D printing. So what you can do is, don't say repair everything. That won't work or give you something that looks weird. What you do is, first you let it only repair the duplicated points. Then you do the analyze again, and in the moment the duplicated points are away, the self-intersections are away. You can close it and you can export the mesh. Let's do this. Like Knopf, File, Exit. Yes, we want to save the whole thing. And to finally prove the validity of that STL, I've loaded it into Mesh Mixer. And in Mesh Mixer I can analyze and nothing happens when I do a repair, so it looks pretty well. So that was it. Again, you've seen a couple of problematics and how to cope with them. You've seen how to create revolutions, you've seen polar patterns, and you've seen how you can finally create valid revolutions of or very polar patterns that don't intersect and give you no problems. And you can also finally see how you can cope with the problems arising by using polar patterns in FreeCAD with the resulting STL files. Thanks for watching. Look forward to more videos from me, and as usual, if you like, you can buy me a beer. Look to my PayPal address that you can see in the description of the video. Bye for now.